In this recording, we're going to look at binomial expansion. In other words, we're going to look at a shortcut to expand something like this, a plus b to the third power, without having to do all this complicated and potentially error-prone computation. So this is what we did in class as a do now. We raised a plus b to the second, we got this expression. We raised a plus b to the third, we got this expression. And obviously, if I continue this pattern up, a plus b to the first power is just a plus b, and anything raised to the 0 power, you remember, is 1. Okay, so I want you to look at the pattern that's developed by the coefficients, what's in red here. I've got 1 in row 0 here at the top row. I've got 1, 1 in the next row, row 1. 1, 2, 1, 1, 3, 3, 1, and the pattern continues. Now let's look at Pascal's triangle. Again, we did this in class today if you were there. This is Pascal's triangle, row 0 through row 9. Obviously this thing continues down. We discovered the pattern in class today that a particular row, for example this row, is formed by taking the previous row and applying this little pattern. 1 plus 2 equals 3. 4 plus 6 equals 10. 21 plus 35 equals 56. 28 plus 56 equals 84. That's how we generate subsequent rows of Pascal's triangle. So, look back at this top part of Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. That's what we've got here in terms of the coefficients. Now we just need to examine the exponents. Notice the exponents here. If I'm raising a plus b to the third power, the exponents of a go 3, 2, 1, 0. Well, that's not hard. We can all count. We can all count backwards. The exponents of b. Well, b's not here, therefore b's exponent is 0. B's exponents increase starting with 0. 0, 1, 2, 3. It's as simple as that. Let's look at some examples. So instead of expanding a plus b to the third power, if I asked you to do a plus b to the 7th power, you'd really struggle to write that all out. It would take a long time to expand it out by hand using multiplying. You'd probably make some small errors, and that would be frustrating. Instead, let's use the binomial theorem. First, let's generate the coefficients, the numbers in front of each term. And of course, those come from the Pascal's triangle. They must come from row 7 of Pascal's triangle. 1, 7, 21, 35. Then it repeats in reverse order. So those will be our coefficients. Just writing them down vertically. I think it'll organize it well here. Now think about what a's exponents should do. If you remember, a's exponents started at whatever the exponent was, the overall exponent, and they decreased by 1s all the way down to 0. So a's exponents should go from 7 down to 0. B's exponents should do the reverse. Start at 0 and increase to 7. Folks, you've done it. Right there you have the expression. We just need to write it out horizontally. So, of course, b to the 0 and a to the 0 we can just basically say are 1s. So it looks something like this. Those are the terms, the 8 terms of the expansion a plus b to the 7th. Pretty easy, right? Next, let's write some conclusions. Let's note, where did the coefficients come from? What happens to the a's exponents and the b's exponents? What's the sum of the exponents in each term? And how many terms are there? So let's look particularly at this one, then we'll make it generalized to a plus b to the n. So the coefficients in this particular expansion came from row 7 of Pascal's triangle. The a's exponents decreased from 7 to 0. The b's exponents increased from 0 to 7. I want you to look at any particular term like this one right here. The sum of the exponents, 4 plus 3. The sum of the exponents, 5 plus 2, or 6 plus 1. So it's no surprise or coincidence that the sum of the exponents is always equal to the overall exponent, 7. And how many terms are there? Well, in this case, because I'm counting a's exponent from 7 to 0, those are 8 terms. I want you to write this on your paper and write a conclusion for what it would be for a plus b to the n power. Then play the recording, check your answers once you've actually written the questions and written in what you think the answers are. Okay, hopefully you had a chance to write in your answers. If not, pause it and write them in. These are the answers. They would come from row n of Pascal's triangle as opposed to row 7. A's exponents decrease starting with n down to 0. B's exponents do the opposite. They start at 0 and go up to n. Sum of the exponents, well, before it was 7, so in this case it's n. And there are always n plus 1 amount of terms. All right, do a couple more examples. Okay, I'd like you to try to work this one out on your own. X minus 2 quantity cubed. I'd like you to begin by writing out what you think the coefficients are, the numbers in front of the variables from Pascal's triangle. Then talk about what x's exponents are going to do, and then what negative 2's exponents are going to do. Keep in mind, negative 2's got to be in parentheses. Then play the recording when you've got that written out. Let's do the same columns approach that we did before. Okay, so hopefully you had a chance to write that out. The coefficients are from row 3, 1, 3, 3, 1. The x's exponents go down, 3, 2, 1, 0. Negative 2, in parentheses, exponents go 0, 1, 2, 3. Now keep in mind, when you raise a negative to an odd exponent, it's negative, right? When you raise a negative to an even exponent, it's a positive. Let's simplify. Okay, so the simplified form of all this is x cubed. Of all this, negative 2 times 3 is negative x squared. 4 times 3 is 12x. And then finally 8. So we write it all out in this format. Notice, it's no coincidence. The terms alternate positive, negative, positive, negative. That'll always be the case if you have a negative subtraction in the binomial. So you've gotten pretty good at doing expansions. However, what if I asked you a different question? I asked you to jump to a particular term, like the third term, in a particular sequence. Well, you could probably figure out the third term of a sequence to the 7th power. What if I asked you for like the 13th term in this sequence, and the exponent here happened to be a 17? You definitely don't want to expand that all out, and you don't have to. You don't need to know all the terms. You just need to know one of them. So, let's do a little warm-up. I want you to write this on your paper, 4C0, 4C1, all the way down to 4C4, and evaluate that on your calculator. In other words, how many ways are there to choose 0 objects from 4? How many ways are there to choose 1 object from 4? So use your calculator to compute each one of those combinations, and play the recording. So, 4C0 is 1, 4C1 is 4, 6, 4, 1, etc. Recognize that sequence of numbers? Oh yeah, that's row 4 of Pascal's triangle. That's some math magic right there. 1, 4, 6, 4, 1 can be found by doing combinations, can also be found by writing out Pascal's triangle. Interesting. I think we've unlocked the key to be able to jump to a particular term without writing in all of the terms. Just need to formalize this a little bit. Now, this is the binomial theorem that's written on your reference sheet, on your green book, and will be on your Regents. But you'll probably never use it. It's not that it's not useful, it's just that you already understand how to expand out a particular expansion of a plus b to the n. However, let's look at this and see if this can make any sense for us. For example, if I'm expanding a plus b to the n, we said the coefficients would come from row n, right, of Pascal's triangle. Well, here they are. They're right there. We said the nth row of Pascal's triangle starts with nc0, nc1, etc. Ends up with ncn. Those are the coefficients. We said that the a's exponents would start at n and go down each time, n, n minus 1, n minus 2, n minus 3, n minus 4, all the way down to 0. And of course, the b's exponents start at 0 and go 1, 2, 3, 4, up to n. So this looks very complicated, but hopefully you see where the pieces come from, which makes you smart. So let's apply this. Let's figure out, using the binomial theorem, where the particular terms come from in this expansion. So we're going to start with the C notation. Instead of looking at the Pascal's triangle, we're going to say, okay, that's 4C0, 4C1, etc. down to 4C4. Then do what you always did. X's exponents. 4, 3, 2, 1, 0. Y's exponents. 0, 1, 2, 3, 4. Now we just need to simplify. So you'd go to calculator, work out each one of these C notations. Works out to be 14641. Along with our particular variable expressions. There's our answer, just written in vertical form. Now, I think we're ready to do this question. Find the third term in this particular sequence, v plus 2 to the w quantity to the 7th, without writing out all the terms. Alright, you gotta concentrate here. So, first off, we're going to do our C notation. We're just going to get the 3 terms. Notice it goes 7C0, 7C1, 7C2. So the third term, this is really where you want to concentrate. The third term has 7C2, one less than the term we're going to try to find. And of course, the left side, the amount that we're choosing from, is always the overall exponent of the 7. Alright, what's happening to our V's? Well, they start at 7 and decrease. So the third term in that sequence is 7, 6, 5. What do our two W's do? Remember, they start at 0, they go up. 0, 1, 2. This is the term we want right here. I want you to notice some stuff. Notice that this 2 is 1 less than the term number that I'm trying to find. This 2, no coincidence, matches that 2. Well, where did I get the 5 from? Think about it. What we're trying to do is generalize it so we don't have to write out all these extra terms. The 5 is what we have to add to get 7. Remember, the exponents add to 7 in any particular term. Now just simplify this last term. Two squared is 4. 7c2 is 21. 21 times 4 is 84. And you've got your exponents right there. Last example. Now we're putting it all together. Find the fourth term in this expansion. We're not going to write out any other terms except for the fourth term. So, let's start with the C notation. Think about what you think it should be and write it on your paper. What number is to the left of the C? 6. What number is to the right of the C? 1 less, the 3. Now, x needs a particular exponent, but you don't have to think about that yet. Let's think about y's exponent. Y started out at 0, so use your fingers to count. 0, 1, 2, 3. The fourth finger is 3. So the exponent for negative 3y is 3 because of this 3 here. So what x's exponent is whatever we add to 3 to get a 6. Those exponents have to add up to 6. Now just go to our calculator, work out 6c3, which happens to be a 15. Work out negative 3 cubed, which happens to be negative 27. Multiply negative 27 times 15. Put on our exponents. And there's our answer. Thanks for watching.